Before starting the simulation, let's just start the stopwatch. Let's see if we are able to monitor it for around 1 minute or not. So you see 5 seconds has passed. We have around 3 bits now.
Hello engineers, welcome to the new video of the course, and in this particular video we are going to see that which kind of sensor we are going to use and why exactly we are going to use that particular sensor. Okay, so let's start with the very first question of this particular session, that which sensor should we use. It's my request to you all guys that you please pause this particular video over here and try to think in your mind. But let me also give you one hint that the sensor that you are going to use, it should be non-invasive. It should be non-invasive, meaning is that the sensor, or basically we should not cut or tear any part of skin. Okay, so it should not cut or tear any part of skin. Cut or tear any part of skin. Any part of skin or in any part of body as well, right? So this is the idea. Okay, so this is kind of hint for you all guys. So it's my request to you that you please pause this particular video over here and please try to think in your mind. Alright, I believe that you all guys might tried your best to guess the answer. Now let me give you the answer. The sensor that we are going to use is, or it should be, an optical sensor. It should be an optical. It should be an optical sensor. It should be an optical sensor, meaning is that we are going to use the light waves, or we are going to use a light as the medium to detect a certain function of the body, okay, or to detect certain part of the body. Okay, so again the next question is, what should we detect? Okay, what should we detect? So please try to pause this video and try to think that this particular sensor, what activity it will detect in the body. Okay, just try to think in your mind what this particular optical sensor would be detecting. Okay, what activity this particular optical sensor it would be detecting. Just pause this particular video and try to think. Alright, I believe that you all guys might have a guess that what exactly it will be detecting. So now let me proceed further and we will see what exactly all of these particular optical sensors do. Okay, and what exactly it should detect. Okay, so we should read this particular line. I had just taken certain screenshots of certain PDF, certain research papers and all. Okay, and we will just try to understand the working of this particular sensor and what exactly we will get at the output of this particular sensor. This is what our concern is. Okay, so let's just try to read out the sentences which are mentioned over here. So basically we are going to use reflection type pulse sensor. Don't worry about that, I'll explain you this particular part. So we are going to use reflection type pulse sensors, okay, which emit infrared, red or green color light. So that means what? We are going to use optical sensor, as it has been clearly mentioned, optical sensor, right, which will emit this kind of light, that is infrared, red color light, or it can emit green color light as well. You can check its wavelength, it is 550 nanometer, right, towards the body, and measure the amount of light reflected using a photodiode or a phototransistor. Oxygenated hemoglobin present in the blood of arteries has the characteristic of absorbing incident light. So you can clearly see what it has been mentioned over here. Let me just erase this particular points. Let me just take different color to highlight this particular point. See, oxygenated hemoglobin, okay, present in the blood of arteries has characteristic of absorbing incident light. So by sensing the blood flow rate, that is change in the blood vessel volume, that changes following the heart contraction over time, we are able to measure the pulse wave signal. Okay, so I know you all guys might find it little tedious to understand at the very first glance, but don't worry, we'll try to understand it in better way. So for that, let me again proceed further. Okay, so again we will read this particular sentence which is mentioned over here. Okay, so the sensor that we are going to use is photosplethography or PPG sensor. You can clearly look over here. PPG sensor is known to be very challenging, as illustrated in figure 1, that means this particular figure. Light emitted by PPG sensor is mostly absorbed by the body tissues. The amount of light reflected depends on the several factors, one of which is volume of arteries near the skin surface. Blood in arteries and arterioles absorb light better than the surrounding body tissues, so as they contract and swell in response to pulsating blood pressure, the intensity of reflected light rises and falls. Okay, so in this entire paragraph, the most important point was this. See, blood in arteries and arterioles absorbs the light better than the surrounding body tissues. Okay, so as these particular arterioles or arteries, when they contract, you see, when they contract, the intensity of the reflected light, reflected light, it rises. Okay. On contrary, if you look over here, let me take certain different color. Yeah, when this particular arteries get swell, okay, when this arteries get swell, the intensity of the reflected light, it falls down, and you can clearly see over here. See this particular condition that let me take this particular color only. See over here, see, try to see this particular part. See this particular part. When I'll take certain different color, maybe I'll go with this one. Yeah, see, try to see this particular part. Okay, only this particular part of the artery. So this is my artery, and what we can see is that the artery is contracted. Artery is contracted, and during this particular situation, you see, whatever the light that is emitted by this particular LED, or in general emitter, is being reflected back. Almost, majority of the light, it is being reflected to the detector side. So whenever we talk about any optical sensor, so we have one emitter and we have one detector. If you could remember in the line follower robot as well, I had clearly mentioned that in IR sensor as well, we have one emitter and we have one detector, or I can the another name for that as well, that was a transmitter and a receiver, right? So same logic is being applied over here. You see, emitter is emitting certain light of certain wavelength, right? And majority of the light, it is getting reflected back to the detector side, right? Now you just look over here, the second diagram over here. Just have a look. When my artery is expanded, okay, or it is swelled, right? So let me just write over here. When this particular artery, it is expanded or it is swelled, right? You can write anything. So artery is expanded. When this particular artery is expanded, so what is going to happen? You see, this time, you will hardly see that light is getting reflected back to the detector side. That means what? This artery which is swelled, it is trying to absorb the light. Okay, so let me just write over here. This particular artery which you are seeing over here, it is trying to absorb the light. So this particular portion, it is trying to absorb light. This is what I can say. Okay, whereas you see this particular part, the contracted part of the artery, it is trying to reflect the light. Okay, it is not absorbing that amount of light. Okay, whereas if you see this particular part, the swelled part, or the part of artery which is expanded, right, it is trying to absorb certain light. Okay, and you see very less amount of light, it is reflected back to the detector side. Okay, great. I hope you are able to understand this particular concept. Great. So now again, there is one question from my side, that what can be the logic or reason behind that? If you look over here, when my artery is contracted, majority of the light is reflected back to the detector of the optical sensor, okay, which is present above the skin, right? On contrary, if you look over here, the majority of the light which is been incident on this particular artery, on the swollen artery or the artery which is expanded, so majority of this light is being absorbed and very few amount of light is sent to the detector side. So what is exactly the reason or logic behind that? Can anyone guess the logic or the reason behind it? Okay, so I request you to pause this video and try to think in your mind. Alright, I believe that you all guys might have thought the answer for it or might have guessed the answer for it. So now it's my turn to give you the appropriate logic for that. So let me proceed further. Okay, and you see, when I say that my artery is contracting, okay, that means I'm talking about this particular event. Just a second. As I had already mentioned, that means I'm talking about this particular event. See this one. Okay, and you can clearly see over here the artery. What does artery contains? Artery contains blood, right? And what the blood has hemoglobin molecules. Okay, I'll just write over here. Let me add one more page. Okay, so let me just write over here. Blood is present blood is present inside the arteries, right? And what does blood have? Blood has hemoglobin molecules in it, right? Blood has hemoglobin molecules in it. Blood has hemoglobin molecules in it, right? And there is one property of hemoglobin, that it binds with oxygen, or rather oxygen molecules binds with hemoglobin. Oxygen molecules binds with hemoglobin, right? Hemoglobin. Oxygen molecules bind with hemoglobin. So this is the working principle. See over here, if you look at this particular part, when my artery is relaxing, or basically when my artery is contracted, you just have a look over here. Let me change the color. Yeah, when my artery it is contracted, so I'm talking about this particular interval. So when it is contracting, you can clearly look over here that the hemoglobin molecule that is present over here, it is very less. In fact, you can see in this particular image as well, there are, I think, hardly 1 or 2 hemoglobin molecules that are present over here. You see, this is my blood vessel and this is the hemoglobin that I'm talking about. So the hemoglobin molecule present inside this particular artery, so I'm talking about this particular point. Okay, the hemoglobin molecule present over here, it is very less. Okay, so during this particular time, whatever the light that is being emitted by this particular LED, okay, whatever this particular light which is being emitted by this particular LED, it will be incident on this particular blood. Okay, and since there are very less hemoglobin molecule that are available over here, so the majority of the light will be reflected back, and then it will be detected by this particular photo detector. Okay, again I'll repeat. You see over here, whatever the light that is being emitted by this particular LED, it will be incident on this particular blood. But since this particular blood has very less amount of hemoglobin molecules, that means very less oxygen in it, right? So majority of this particular light would be reflected back to the photo detector. Okay, so this particular light, or the reflected light, would be detected by this particular photo detector, and that's why if you look over here, during this particular interval, when my artery is contracted, or when it is relaxed, so you see we are getting certain high pulse over here. You just have a look over here, we are getting certain high pulse. Okay, we don't know what is the voltage of this particular signal. Okay, that is not the point of our interest. What we can say is that we are getting majority of the light, and due to which we should get a kind of high pulse over here. Okay, great. Now let's proceed further to the next case. You see, when my arteries they are expanded, you just have a look over here. When my arteries are expanded, I don't know if it is visible to you. You see, when my arteries they are expanded, that means I'm talking about this particular case. See, I'm talking about this particular case. Okay, so let me just highlight it over here. So I'm actually talking about this particular case. When my artery is expanded, you can clearly see, the hemoglobin molecules that are present inside the blood. Okay, they are now more in number. Why? Because my artery is my artery is expanded, right? So you see the amount of blood present in this particular area, it also increases, right? And when I say that my the amount of blood present inside the artery, it increases, right? Let me just show it to you over here. Yeah, when I say that the amount of blood which is present inside the artery, it increases, that means the hemoglobin molecule which are present inside that particular blood, that also increases. That means what? The presence of oxygen inside that particular artery, it also increases, right? So due to this, what is going to happen? Just now, if you could remember, we read this particular sentence that oxygenated hemoglobin, you can clearly look over here, oxygenated hemoglobin present inside the blood of arteries has characteristic of absorbing the incident light. Okay, so this is the most important line. Okay, and that's why I had intentionally highlighted this particular point over here. Okay, so during this particular scenario, since we have a lot of oxygen present inside this particular artery, so the majority of the light, as you can see over here, which is incident on this particular artery, or rather on this particular blood, it is going to be get absorbed by this particular hemoglobin molecule, and you see very less amount of light is getting reflected back to the detector side. Okay, and you see during this particular interval we are getting very low pulse. Okay, we are getting a signal. Just a second. Yeah, you see we are getting this kind of signal, which indicates that light which is being received by the detector, it is very less in number, or the amount of the light, it is very less, and that's why you see we are getting this kind of curve, something like this. Okay, great. I hope you are able to understand this. So this particular part is nothing but our sensor part. So our sensor is detecting all of these particular things. Okay, our sensor is detecting all of these particular things. Again, we will repeat each and everything in detailed way so that it would be pretty easier for you all guys to understand it in much more detailed way. Okay, so let's start over here. Okay, so the first point that we discussed was we are going to use an optical sensor, and when I talk about an optical sensor, so optical sensor has two important components, that is, one is transmitter, or sometimes it is referred as emitter, and the another important component is receiver, or sometimes it is also known as detector. Great. So now let's proceed further, and we in this particular image we saw that it has been mentioned that the oxygenated hemoglobin has the tendency to absorb the light, right? That means the hemoglobin molecule which are present inside that particular blood has tendency to absorb the light. Great. So now let's proceed further. With this particular image, what we understood is that when my artery, if you look over here, when it is contracted or when it is in relaxed position, so the reflected it tries to reflect a high amount of light, right? On contrary, if you look over here, the swollen part of artery, that means when my artery is expanded, so the amount of light that has been given to this particular detector or reflected by this particular artery, it is very less. Why? Because majority of the light which is incident on this particular artery or on this particular swollen artery, it is being absorbed by the detector. I hope you are able to understand this part. And what is the reason or logic behind it? This is because the swollen artery has high amount of hemoglobin molecules, and hemoglobin has oxygen, right? So oxygen, or rather hemoglobin molecule, absorbs all of this particular, or rather majority of this particular light, whereas this relaxed artery or the contracted form of artery, it has tendency to reflect the light. Why? Because you will hardly get any hemoglobin in that particular area. Okay, and with this, I mean, whatever the signal that this particular photo detector detects, this is the signal that it that we should, or rather that particular sensor will receive, or rather this particular photo detector will give, right? So you see, yeah, this is the signal that the photo detector will give. Okay, you see, this is the signal that the photo detector is giving, right? Now obviously this is what, this is one analog signal. So let me just write over here, this signal is an analog signal, right? And obviously there would be certain signal conditioning circuit. This signal will be very less. It would be in microvolts, it can be in millivolts, right? As of now, that is not the point of our interest, right? Most important thing is that it will be in analog, and most importantly, it can be in microvolts, it can be in millivolts. Okay, we don't know what exactly it is, and we don't want to go in that detail because we are focusing upon this particular project from the controller perspective. Okay, in some of the video or in some of the course, we will design one circuit and proper sensor for it, where we would be able to detect this waveform. Okay, so don't worry about that. I will make one video on that as well. Okay, just try to understand the logic behind it. Okay, great. So now this particular signal will pass through certain components, that is filters, amplifiers, comparators, ADCs, etc. And this particular entire structure or the entire system combined to form what? A signal conditioning circuit. So a signal conditioning circuit consists of all of these particular components, that is filters, to filter out certain signal, okay, certain frequencies. Okay, then we have amplifiers. Obviously this particular signal, it's in microvolt, it is in microvolt, millivolt, right? So we need to amplify it to certain volts, right? Maybe 1 volt, 2 volt, we don't know, right? Then this signal would be fed to comparator, right? And then it will be given to ADCs and all. Okay, why ADCs? Because we want a digital signal over here. Why digital signal? Because our microcontroller or any of the microcontroller cannot understand the analog signal, right? So you will get ADCs maybe in the controller, but 8051 don't have the ADCs, so that's why that will be present in the signal conditioning circuit only. So over here these ADCs are present to get a digital form of signal. Okay, I hope you are able to understand this. So at the end, I mean, when this particular part is connected to controller, so this will be my digital signal. This will be my digital signal. Okay, so basically over here at the output of the sensor, okay, so this entire structure, see this entire structure, it forms my sensor. Let me take certain different color. Yeah, you see this entire block, it forms what? It forms a sensor. Combinedly it forms as a, collectively it forms as a sensor. Okay, I hope you are able to understand this. This is my controller. Okay, so at the output of this particular sensor, that means somewhere over here I should get a digital signal which should move from low to high, which should move from low to high. That means it should move from 0 to 1. Why 0 to 1? Because we had clearly seen that during this particular interval we will get 0, and during this particular interval we will get 1. So something like this, 0 and 1, something like this, 0 and 1, 0 and 1. Okay, I hope this particular color is visible to you all guys. Just a second. Let me take certain different one. Yeah, you see this will act as a 0. Okay, this and this particular waveform, it will act as a 1, right? 0 and 1, 0 and 1, something like this. Okay, so this is what the sensor will provide, a digital output, okay, or a digital waveform, that is, it moves from 0 to 1, that means low to high pulse, right? Then talking about microcontroller, that is 8051 microcontroller, let me proceed further. Yeah, you see over here this particular signal, that is a low to high pulse. Let me just show it to you over here once again. I know I'm taking a lot of time, but this will actually help us to understand the concept in the proper way, right? So let me change the color to this one. Yeah, so a low to high pulse that we are getting over here, a low to high pulse, that is a signal which we are getting over here, which is traveling from 0 to 1, right? So this particular entire activity, it should be captured by the microcontroller, right? And by the way, if you all guys know that our heart beats constantly, right? So this kind of signal we will be receiving at certain regular intervals, right? So what we need to do is that we need to catch this particular pulse, that is low to high pulse, for around a minute, right? So our microcontroller should detect this 0 to 1 pulse or low to high pulse for 1 minute. Okay, and at the same time it should update this pulse, I mean the count of pulse on the display unit, right? It should update the count of pulse on the display unit. So basically in this particular project, my microcontroller is acting as a counter, okay, or rather I should use my microcontroller as a counter. I hope you are able to understand this, guys. Okay, just try to understand it. What I'm trying to do is that, I'll use my microcontroller as a counter to count the events. And what are those events? These events are pretty simple. That is, I want to catch one low to high pulse, okay, for around 60 seconds, sorry, not 60 minutes, for around 60 minutes, sorry, for around 60 seconds, that is for 1 minute. Okay, I have to catch these particular event. So let me change the color. Our microcontroller should catch the low to high pulse, that means 0 to 1, right? 0 to 1. Okay, we have to, my microcontroller will catch this particular 0 to high pulse and then display it on LCD. Display it on LCD, or if you want you can also use like a graphical LCD, OLED display, anything, right? But to make it little simple, I had only used LCD, okay, because it is quite easy to interface with any sort of microcontroller. Okay, so this is the exact idea. I hope you are able to understand this, guys. Okay, so let's proceed further. Now we will focus upon the microcontroller. Okay, so when I say that my sensor, it is giving certain output to the microcontroller, right? So certain port or certain pin of that particular microcontroller acts as the input pin or the input port, right? So let's suppose I'm getting certain signal. As of now, we saw that what kind of signal I should get. So let's assume I'm getting this kind of signal which is moving from, let me change the color, yeah, which is moving from 0 to 1, right? 0 to 1, right? So I'm getting this kind of signal which is moving from 0 to 1. Okay, I need to take this particular signal. So certain port or certain pin of this particular microcontroller will act as the input pin which will actually take this particular signal, right? So in my project, okay, I'm going to use port 3 as my input pin. Let me change the color first. Yeah, I'm going to use port 3 as my input pin. Port 3 as my input pin, and obviously the microcontroller will process this particular data, right? And then it will show this particular data in the numeric form, right? Which a human being can see that particular number and can actually see what is his or her heart count, right? So that particular data would be sent to one display unit. So this is what, this is my output, right? So this is my output. So I need to connect this particular output system to what? It's up to you, but I'll connect it to maybe port 2. So what I'll do, I'll just write over here. I'll just connect this particular display unit to port 2. If you want, you can connect it to port 0 or port 1. It's up to you, but I'll go with port 2. Okay. So this is the idea of the entire project. I really hope that you understood the logic, that why exactly we are going with optical sensor, because we want a non-invasive technique. That means we don't want to cut any part of skin or our body. On top of that, we also saw that how exactly this particular sensor will work, what kind of waveform this particular detector will receive. On top of that, we also saw that what kind of waveform we will get, plus there would be certain signal conditioning circuit which will actually convert this analog data, that means this particular data, this kind of waveform, to the digital one. That means we need to count the events. Okay, this particular event, that means event in which the signal is or the pulse is getting transferred from 0 to 1, right? So we need to count this for around 1 minute, right? We should catch the low to high pulse for, I just forget to write over here, for 1 minute, or 60 seconds. Okay, or 60 seconds. So we need to catch this particular change in this pulse from 0 to 1 for around 60 seconds. Okay, and then at the same time we have to display it on our display unit, that is our LCD. So for that very purpose, my input would be the port 3 and my output would be port 2. Okay, so I really hope that you understood this particular concept. Okay, but still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I will surely help you out to sort that particular doubts. Okay, so thank you for listening me patiently. I am ending this video over here, and in the next video we are going to get certain idea about the microcontroller, and then we are going to proceed further with it. Okay, so thank you for listening me patiently. I am ending this video over here. Thank you.
Or not. So you see it is giving 0 errors and 0 warnings. So now let me go to the Proteus software and let me just burn this particular entire code. Alright, so now let me just burn this particular code into the into the microcontroller. Click on open, click on OK. Great. And now before starting the simulation, let's just start the stopwatch. Let's see if we are able to monitor it for around 1 minute or not. So you see 5 seconds has passed, we have around 3 bits. Now 10 seconds has passed, we have around 5 bits. 15 seconds has passed, we have around 7 bits. Then 20 bits has passed, we have around 8 bits. 25 seconds and we have 10 bits. 30 seconds we have 13 bits.